Hello and welcome to today's video. It's going to be an update on Nash. So last update I was talking about Nashlib, and I think I said I was done with that and I'd be moving on to Nash, like the compiler, which I have actually moved on to the compiler now. And this is the syntax here, so you can create functions and all that, like my function, and then and then you can return and all that. It only supports one type at the moment, which is integers or int. So next, I think I'm going to be working on either boolean or void, so we can have void functions. So like, I don't know, void like that. Or I was thinking, if we want void functions, we can just do that. That may be easier syntax than typing in void, but who knows? We'll see when I get there. So there's kind of been a change. So last time I was talking about using Nashlib for the backend, so I'll compile to assembly and all that, or assemble whatever, like compile to assembly. But I found that that's very hard, and I think that would take me very, very, very long time to be able to get to even what I've got here, like this. Like, this would probably take me a month or something, probably just to get this, because I'd have to work out the ABI, like sys ABI, sysv, sysv ABI. Then I'm gonna have to work out like allocating space in the stack and all that. It would just be a bit annoying for me. Well, a very long time, and the development would have taken so much longer. Like, this is probably 4 times as quick doing it how I do it. So, how have I been doing it now? Well, if we go to, wrong file, code gen, as you can see, I'm using LLVM and generating bit code now. So I'll show you an example, functions here. So, this environments. So as you can see, it's very easy. I just set a type, which is integers. So I've got a default type here in AST. See, I only got one type at the moment. Yeah, but we get a type. We default to void if don't have one, which would never really happen at the moment, because if the parser forces a type, if you don't have a type, then it gives you an error. So then we basically add the arguments, so here these to the function, or this here, I mean this list. Then we put this list here, get or insert. So as you can see, there it is. Actually, is it? Yeah, doesn't matter. But then down here, we actually create in the environment, so current environment. So it uses like scopes. So, for example, this would be its own environment in these brackets. But I'm gonna work on making it so it can go to a scope up. So, for example, if I define a variable here, I can access it in this scope here. So we have to go up a scope, or up to another global. And then with globals, it goes up another scope, or environment, I guess. So I may have to make a list of environments with a hierarchy, like a tree. So, yeah. So that's just, it's really easy with LLVM, because I just really, if I go down to variables, assign, so all, like with assigning, all I have to do is just create store if it's like a static variable. Yeah, if it's static, you can't do it. But yeah, you just create store. It's really easy, and then writing it out, you just write out the bytecode like that. So let's get, actually, make sure it's all clean. So someone actually has been working on something. So the runtime is going to take a little to implement into it. I've got to implement function calling first off. So I've got to implement it so you can actually run a function. Because at the moment, I've just got this main function, which is the entry point. Well, the entry point is at start, but I mean libc calls main. So yeah. So this is really the entry point. But later on, later on I'll try to put the runtime into the actual, like, compile the runtime into it. So this will become an object. So as you can see in the runtime, it's kind of like the managing memory. So yeah, so we don't really. Yeah, so it looks like I haven't actually looked at this previously very much. I've like, they've been working on this a little. So it looks like they've got a state and all that, and a scope and memory or something. I'll have to ask them what it does. I don't know yet. I've been actually just working on the compiler. So yeah, but it looks good. I think once I've got all this done, then I'll implement or try to get that runtime into the actual code. Because I think what I'll do is this will compile to an object file and then link it with the file. So this is done now. So we'll just clear that. So it should give us a file, Nash, and then we can compile that, and then we should have an output.bc. So I can actually convert that to like readable code. And then we should have output.ll, as you can see. So we have these as arguments, and then we allocate some allocate how much is 4 bytes? Yeah, 4 bytes on the stack for the seer variable, and then we really do the same, and then yeah, so then as you can see, we return the integer, or 32-bit integer to yeah. So yeah, it makes it much easier to compile now, because what I really liked is now that it compiles this bitcode, this actually will run on, well, not run, compile for many different architectures and many different operating systems or something. Because originally with Nashalib, I was going to have to implement different formats, and I was gonna have to like make it compatible with Windows, Mac, and all this. But this is already compatible with all those, so that pretty much all I have to do now. I haven't tested this on Windows or any other operating system except Linux. So once maybe I'll install Windows or something, I will make this compatible with Windows. But I don't have to worry about the backends being compatible at all. So this is kind of a big plus. So it's a big step forward with making it more, well, system independent. So other people can use it on different systems, which I really like. So if we actually compile this, let's see, and then we have to type equals object, and then could do the LL, but I'll do the bytecode. So then we get this output.io, O, and then output.o, and then output, and then we get this output, doesn't print anything because, as you can see, it's just making some variables and returning. Actually, can we... Yeah, when I was using the other shell, I could actually get the return type, because I could probably get, oh, this would be 0, wouldn't it? So, if I did that, maybe if I do that, main.nash, and then, as you can see, it's pretty fast, so I don't have to really worry about speed at the moment, but my parser is tiny, and everything's really tiny at the moment, since I only support, what is it, LC? Yeah, only like a little bit of syntax, so I'm hoping to keep it small and fast. Well, not small, but fast, so it doesn't take forever to compile everything. Yeah, it doesn't show the... Yeah, I'm pretty... that must have been another shell I was using. But yeah, it would print out the thing. So yeah, that's what I've been up to. So next, I'm going to be implementing function calling. And then I'm going to have function prototypes and then external function prototypes. So I can have like, this is the syntax I use, proto, and then printf, and then, what would I call that? I just, no, it was like, yeah, and then int. So that's what a function prototype will look like. Or an external, actually no, that wasn't what I was going to do. External proto. So that would be, and then a normal one, like in the file, would just be basically the same with all that in it. Yeah. So that would be external, and I'm going to implement after that more types. So I'd have characters and pointers. And I'm going to implement importing files, so then I can get started on implementing a simple standard library. And then after I've got all importing and all that, it should be stable or usable enough to be able to get the runtime in it, and then it should be all working. So yeah, I think that's all for today. And yeah, if you like the video, like and subscribe, and I hope to see you in the next video. And if you've got any questions, put them in the description. Also, I've got the GitHub link in the description. I've got the Discord server in the description. And also, there's a server called I think it's called Computer Science Society or something. I can't remember right now, but it's a pretty cool server. But I've got a committee on there for computer programming that you can speak about programming, make updates about your programming language and what you've been up to, and get help with it, and people can help you and all that. So it's pretty cool. I'll put the link in the description for the invite link to that. And the committee should be called Program Languages or Program Language Development. Can't remember. Pretty sure it's Program Languages. And yeah, and my profile should be on there. I'm the executive director. So if you have any questions, you can ask me. And yeah, so that's all for today. Yeah, so hope I see you in the next video, and see ya.